Okay guys, so in this video we are going to move away from factoring and start the second portion of this unit, which is the quadratics portion. I like to group these two things together just because they have so much in common. I mean, you use factoring as one of the methods of solving quadratic equations, so it kind of makes sense to start with factoring and then roll right into quadratics. So we're just going to jump right in and get started with the quadratics portion of this unit. So what exactly is a quadratic equation? You have seen these before, you just maybe haven't known what they were or how to classify them. But when we started talking about polynomials, we talked about this briefly. Any equation where you have a squared variable as the highest degree is a quadratic equation. So the name quadratic comes from the root word quad, which means square. And it is referred to as that because that lead term is always got a squared variable. If the equation's biggest exponent, I'm just going to write expo because you know mine is a long word. If the equation's biggest exponent is 2, then you've got a quadratic. And you always want to make sure that you get your quadratic equation in standard form. Okay, if you are given just a trinomial and it happens to be a quadratic trinomial, you're not going to set it equal to 0. That's really only when we're talking about quadratic equations. Remember, the equal sign is that differentiator between an equation and an expression. So if I'm asking you to factor something and it happens to have x squared, that's cool. But if we're dealing with quadratic equations, you got to make sure that you've got that set equal to 0 and that it is in standard format. So standard format is ax squared plus bx plus c. You've got your squared variable first, you've got your singular variable here in the middle, and then your constant at the end, and it's set equal to 0. In this format, a cannot be 0, because if a is 0, then 0 times x squared would make this 0. You wouldn't have an x squared, you wouldn't have a quadratic. So a can't be 0. A, b, and c are known values. If you have another variable in place of a number for a, b, and c, or if it says bx, or ax, you know what I mean? Like if there's a variable there instead of a number, then you can't solve it this way. We cannot solve when we've got unknown values for a, b, and c. They have to have numbers in their spots. And then x is the only unknown variable. And you'll see it in the equation twice for the x squared as well as the x. Just like up here, this is a great example of a quadratic equation. You've got 5x squared plus 3x plus 3 equals 0. Okay, so let's look at some examples. 2x squared plus 5x plus 3 equals 0. So in this equation, what is the a value? What value is in that a spot? If you said 2, you would be correct. What about b? If you said 5, you would also be correct. And what about c? If you said 3, then you're on a hot streak. Okay, because these are both plus signs, then we know we have all positive values, but if any of these were subtraction signs, then the numbers would be, you know, -5 or -3, depending on where that subtraction sign landed. You always carry the sign into the value of that coefficient. So this is a great example. We're already in standard form. We know this is a quadratic equation, no problem. A textbook example, I would say. All right, what about this second example? X squared minus 3x equals 0. What do you notice about the terms? We're missing one, right? If I put this in ax squared plus bx plus c, I'm missing somebody. A is 1, because I don't see it, so it's invisible. Must be a 1. B is -3. The b term is always the one that has the x with no exponent, okay? And since there is no c term, there's no constant, what do we understand that to mean? C equals 0. All right, and it's really important that you understand that in this case, I know sometimes I tell you, oh, if something equals 0, don't waste your time and energy writing it down. But when we get to solving using the quadratic formula, it is going to be imperative that if you have a known value that is 0, you still need to make note of it because it will change the value of the quadratic formula radically. So you have to make sure you write it down. Okay, what about this next example? 5x minus 3 equals 0. What do you notice about these terms? Again, we're missing one. We've got an x that is a first degree variable, so this must be our b value. And we've got a constant, so that must be our c value. We are missing the x squared term. Since there is no x squared term, this equation is not a quadratic. Okay? You have to have that squared variable at the lead of the equation, or once you get it into standard format at the lead of the equation. You might not be given that format, but you've done some rearranging. That must be the highest degree exponent in this equation in order for it to qualify as a quadratic. If you don't have an x squared, it's not a quadratic. If you have an x cubed, also not a quadratic. That's something completely different. That's a cubic equation. All right, and on down the line, x fourth, x fifth, no, we don't want it. I only want x squared when I'm talking about quadratic equations. Okay, so let's move right along. If you flip your notes, here we go. Sometimes, wait for my camera to focus, maybe. There we go. Sometimes a quadratic equation will sneak up on you and present itself in disguise. So tricky, those quadratics. Remember that you always need to get your quadratics into standard form. If you don't, you will not be able really to utilize any of the methods of solving. You could, I guess, use... No, you know what? I'm going to stick with my original statement. Just get it into standard form. Don't ask questions. Just do it. All right, so let's write this so we remember. Ax squared plus bx plus c equals 0, where a, b, and c are known values. Okay, so if I have x squared equals 3x minus 1, how do I fix this? Well, x squared equals 3x minus 1. I'm going to subtract 3x from this side and this side. And that's going to give me x squared minus 3x equals negative 1. So if I add 1 and add 1, I will get my standard format of x squared minus 3x plus 1 equals 0. Now you might say, well, Ms. Thompson, why didn't we just bring this x squared to the right side instead? That would have left us with negative x squared, which we can't have. So if we had done that, we then would have had to change the signs on this whole side completely, which is why we wind up with x squared minus 3x plus 1 equals 0. All right, so our a value in this case is 1. Our b, if you said negative 3, you'd be correct. And our c is also 1. Okay, let's try this second example. Sorry I didn't give you more room in this box. And actually, I'll do this distribution here. We need to distribute this here first. So we get 2w squared. So distribute it here. And I'm going to distribute over here. And that's going to give me 2 times 2 is 4w equals 5. All right, so I know my equation has to be set equal to 0, so I've got to get this 5 here on the other side. If I have 2w squared minus 4w equals 5, I'm going to subtract 5, do the same thing to the other side. So in standard form, I've got 2w squared minus 4w minus 5 equals 0. That means my a value, my b value, and c value, let's see, a is going to be 2, b is going to be negative 4, and c is going to be negative 5. As long as you have this in standard format, figuring these out should be no problem. But if you take something that's given to you like this and try and mentally work it out, well, I have no doubt you can do it, there's a bigger margin of error there. So just go ahead, get it in standard form, Once you get the, process down, this will be like second nature. You'll be able to do it so fast. All right, we're going to do the same thing here. We need to distribute. So I'm going to get z squared minus z equals 3. So what do we need to do here so that we can have this set equal to 0? We need to move the 3 to the other side, and we're going to do that with subtraction because it's a positive 3, which means our standard format will be z squared. Trying to make sure my 2's don't look like z's and vice versa. Minus z minus 3 equals 0. Okay, so that means A, B, and C. A, I don't see an A here, so it must be my invisible 1. Same thing here. I don't see a B. It must be my invisible negative 1 because I've got a subtraction sign. And for C, I actually can visualize the number, and it is a negative 3. All right. I hope that is helpful in figuring out once you get everything, well, how to get everything in standard form, and then also identifying A, B, and C. If you need a refresher on how to move things around in an equation, then please let me know. Inverse operation and all that good stuff, balancing both sides of the equal sign. Okay, so moving right along, what is the point? How do I solve these things? I understand that I need to have it in standard form, and I've got an equal sign, which means I must be able to solve. I only have one variable here in this equation, and it's x, which means, yeah, I should be able to figure out what the value of x is. So how do I do it? I'm so glad you asked. The solution to a quadratic equation is any value for that x variable that makes the equation equal 0. It's set equal to 0 when it's in standard form, so that's what we want it to work out to equal, right? We need to make sure that whatever the value of x is, when we plug it in to that format, to that standard equation, it's going to equal 0 in the end. So when we're talking about solving, this is critically important. Get out your highlighters and highlight this whole section, because I guarantee if you have a quiz or when we have our unit test on the 31st, you will be asked this question, because we are going to use these terms interchangeably in class, and you cannot be like wondering what the heck is she talking about. So when we're talking about solving, these terms can be used interchangeably. They all mean answer. If I'm talking about getting the answer to a quadratic equation, I am talking about the solution. We know that. That's kind of a no-brainer. We use that term all the time. It can also be called the root. It can also be called the 0. Makes sense because I want the equation to equal 0 in the first place, so the solution we sometimes call the 0. Or we can call it the x-intercept, and we'll get to that, to why that is in just a moment. Okay? So we can also call it the x-intercept. Solution, root, 0, x-intercept. Commit it to memory, never forget. And there are 3 different methods for solving quadratic equations. There's graphing, arguably the easiest, but I don't want to say the least reliable, but just it is going to work the least amount of time. And as soon as we talk about graphing, you will understand exactly what I mean by that. So graphing, factoring, again, not going to work every time. And quadratic formula. Going to put a big old asterisk next to quadratic formula, because the quadratic formula will work every single time that you are trying to solve a quadratic. And actually, for Algebra 2, there's a 4th method that we are going to learn called completing the square. This is a little bit more of an advanced concept that my Algebra 1 kids don't learn, but Algebra 2, you will learn completing the square. Okay, let's just back up the truck here for a second. What do I mean when I say it will work every time or it won't work every time? If it's a method of solving something, isn't it supposed to work? We're supposed to solve. Think about a solution to a problem. If I want this solution to be in the form of a whole number, that's great, but what if the actual solution is not? We learned about the imaginary number I. What if it is very possible the solution to your quadratic equation includes I. You're not going to be able to see that in your calculator when you're graphing, and you're certainly not going to, work that out by factoring. The only way you're going to get to that irrational solution that includes the imaginary number I is by using the quadratic formula. So if the equation that you're presented with is one that's all nice and pretty, and it's going to come out with just these nice little whole numbers as your solutions, then yes, graphing and factoring is the way to go. But if that's not the case, and you won't really know that by just looking at the equation, right? You kind of have to get into the nitty-gritty of doing it to figure that out. The only way to get the solution when you have something imaginary is by using quadratic formula. So if you are instructed to use graphing or factoring, please do. If that's kind of your go-to method first, but you can recognize that it doesn't work and then move on, that's fine. Me, I like to just use quadratic formula every time because I think it's pretty fast. But I'm going to teach all of them to you so that you have all of those methods at your disposal. So the first one we're going to talk about is graphing. When you graph a quadratic, say that 5 times fast, it makes a pretty little curve called a parabola. And I'll show you a picture in just one second, even though you've probably seen it before. It makes a pretty little curve called a parabola. The places where the graphed equation crosses the x-axis, which is the horizontal one, those are the solutions of the equation. That is why one of the words for answer that we use is x-intercept, because the spot where that parabola intercepts the x-axis is a solution. So while the solutions are ordered pairs or points on the line, you will not write them in ordered pair format, x and y. Instead, you'll put both the x values into curly brackets. And the point where the parabola changes direction is called the vertex, which you may be asked to identify as well. Okay? So, let's take a look. Take a look at the graph below. Can you tell what the zeros of the equation are? Oh, what's a zero, you ask? Remember, that's one of the words that we use interchangeably to mean answer. So what is the answer? What is the solution of this particular graphed quadratic equation? It's the spot where the line crosses the x-axis. So I've got one right here at 2 and one right here at -3. So that means that my solution for this quadratic are -3 and 2. I only write the x values in those curly brackets. All right, it is possible that when you graph, you will see this, which means there's one solution, or you might see something that looks like this. If you don't intercept the x-axis at all, what do you think that means? If the solutions are the spots where the line crosses the x-axis and you have a graph that is not touching the x-axis at all, what could that mean? It means that there is no solution. And this one would be one solution. Okay? So even though your method of solving may spit 2 numbers out at you, that doesn't necessarily mean that they work. You got to go back and check them to determine if you're going to get 2 solutions or 1 solution or even no solution. So how do we graph this? We're going to try this example, x squared minus x minus 2. And I'm going to get my calculator here on screen so you can follow along while writing. Okay, so we are going to hit the y equals button in the top left. Y equals. Going double duty here. Okay, type in the equation that you want to graph, and you will not include. There we go. Okay, so you're going to type the equation that you want to graph into that y equals, and you will not include the equals 0 part. So I'm going to type in x squared minus x minus 2. Okay, that's what I'm going to type in. You're not going to include the equals 0 portion. Okay, and then you're going to hit the graph button up here in top right to see your parabola. Well, look at that. Isn't that nice? Crosses the x-axis in 2 spots. Awesome. So sometimes you can tell by looking at the picture what the solutions are. But just to be sure, let's look at the table. So you're going to hit the yellow second button. And then the graph button. And that's going to give you the table. You want to look for a 0 in the y column. A 0 in the y column means that you have not moved up and down vertically off of the x-axis. It means that in that ordered pair, your y value is 0. So you're on the x-axis. You're on that horizontal line. So if I've got a 0 in the y column, that means that the point is hitting the x-axis at whatever number corresponds. So in this case, the number next to it is the solution. This is -1. I know that it crosses the x-axis twice, so I should have 2 zeros in the y column. And in fact, I do right down here, where y is 0, x is 2. So that means that my ordered pairs would be -1, 0, and 2, 0. Let's go back to the picture to see if that makes sense. And let me zoom out. There we go. So you can see by looking at this picture, I've got a point on 2 and I've got a point on -1, which is exactly confirming what the table told me. Your notes should say number here. Which means that the solution for this equation would be -1 and 2. So why do we have two solutions for a quadratic equation? There's going to be 2 different x values, right? If you have x squared, you've got 2 potential options there. When you have that squared variable, that means that your maximum number of solutions is 2, but it doesn't mean that you will most definitely have 2 solutions. So it's always important, if you're not able to see a picture of the graph, to check the solutions that you get into the equation to make sure that they wind up equaling 0 for the whole expression. All right, so that's graphing. It's pretty straightforward. You just need to remember y equals, type in the equation, and then check out that table. But remember how I said it wouldn't work every time? This graphing method will only work if you have whole numbers for your solutions. Let's say that parabola crossed the x-axis at a decimal, maybe -0.5 or 2.75. Unless you have your calculator programmed to show you your table in those specific, 1/4 increments, then your solutions wouldn't even show up. So even though you're looking at a picture of a graph that very clearly crosses the x-axis, unless it crosses at a whole number, or you have miraculously programmed your calculator, ahead of time, unwittingly, to be in those different proportions, whatever fractionally proportion it may be, then you will not see it in the calculator. And that's why we say that graphing doesn't always work, because you might not have your calculator set up to read the table in whatever decimal point your solution might have. If it is a whole number, great, it's going to work perfectly for you. But if you type your standard form equation into your calculator and you don't have any zeros in the y column, then you know something's wrong and you need to move on to a different method of solving. So the next one that we would try would be factoring. We just talked about factoring. This should be very fresh in your mind. And there's just like 2 extra steps beyond normal factoring for using it to solve quadratics. So the first thing we would do would be to get our equation into standard format. You are going to hear me say standard format about 10,000,005 times. Get used to it. If the equation that I'm giving is x squared minus 3x equals -2, then I need to get this -2 onto the other side in order to set it equal to 0, and I'll do that by adding 2 to both sides. So I'll get x squared minus 3x plus 2 equals 0. Okay, now let's factor. I have a trinomial and a naked variable, so I need to find out what multiplies to C and adds to B. Sorry for my very strange abbreviations, but I'm running out of room. I need to learn to write smaller for these things. So if I've got x squared minus 3x plus 2, what two numbers multiply to 2 and add to -3? I've got a plus sign here, so I know the signs in my two sets of parentheses will be the same. My sign in front of B is a subtraction sign, so I know that both of my parentheses are going to have subtraction. Split up my x. What two numbers multiply to 2 and add to -3? Well, really the only factors for 2 are 2 and 1, right? So -2 and +1 will multiply to +2 and will add to -3. Awesome. We know how to do this. We've done this before. We just spent days doing this. So what's the difference? Next, we're going to take one of the factors, and we'll start with x minus 2, and we're going to set it equal to 0. The equation was set equal to 0 in the first place, and we kind of just forgot about it here. Well, we got to bring it back into play. Because remember, these factors, we're looking for the value of x that will make the entire equation equal 0. So we're going to set each of the factors equal to 0 in order to make that x work out. So x minus 2 equals 0. And now I'm going to solve for x by doing what? Moving the 2 to the other side, getting x by itself, and I get x equals 2. Now I'm going to do the same thing for the other factor. I have x minus 1 equals 0. Well, I'm going to move the 1 to the other side to get x by itself, and I get x equals 1. Seems easy enough, right? Don't forget about our last steps. Check your answers by plugging them into the original equation. So I had x squared minus 3x plus 2, and we want it to equal 0. I'm going to start with 2. 2 squared minus 3 times 2 plus 2 equals 0. 4 minus 6 plus 2. Does that equal 0? 4 minus 6 is -2 plus 2. Yes, indeed. That one equals 0. So we know that 2 works as a solution. Let's try the same thing for 1. 1 squared minus 3 times 1 plus 2 equals 0. 1 times 1 is 1. Minus 3 plus 2 equals 0. Well, 1 minus 3 is -2 plus 2. Yep, it looks like this one is going to work out also. So that means both 2 and 1 are our solutions. We're going to write our solutions that work in curly brackets. We've got 1 and 2. And if you were to put that into the graphing calculator and check out the graph, it would show you the exact same spots for the x-intercept. Okay, so if you have any questions, rewind this video and watch it again. And if you still have questions, then write them down and we will go over them in class first thing and then do lots of practice. Great job, you guys.